So welcome back, students, for the discussion of some important questions in ratio and proportion. Which I have given you in assignment. Okay. So the first doubt is question number 1B. In which given A is to B is proportional to C is to D is given. So if A is to B is proportional to C is to D is given, then we write it A by B equals to C by D equals to K. This is the K method. And if A by B equals to K, so A equals to BK. And C by D equals to K, so C equals to DK. And in question number B, we have to prove 2A plus B plus 4C plus 2D is to 2A plus B plus 4C minus 2D equals to 2A plus B minus 4C minus 2D is to 2A minus B minus 4C plus 2D. So try to prove starting from LHS. It will make the concept clear. So when we start proving, in place of ratio, we write it in fraction form. 2A plus B plus 4C plus 2D is to 2A plus B plus 4C minus 2D. Now we use as our assumption, that is the assumption which we have assumed, A equals to BK and C equals to DK. So in place of A, we will write so in place of A, we write BK. In place of C, we write DK plus 2D over 2 into BK plus B plus 4 in place of C, DK minus 2D. Again, in next step, always draw this line first. And then in first two, B is common into 2K plus 1. In next two, 2d is common. So 4dk upon 2d is 2k plus 2d upon 2d 1. And in denominator, if you observe, again b is common. So 2k plus 1 plus this is question number 1b. It is 2a minus b in place of b. Okay, okay. So the mistakes can also be observed easily, can be searched easily. Whenever we solve it, in place of plus, this has minus, na? 2a minus b in place of a, it will be bk, 2k minus 1, 2d common into 2k minus 1. In next step, we observe that 2k plus 1 is common between these two terms. So if we take 2k plus 1 common into b plus 2d over in denominator also, 2k minus 1 is common into b plus 2d. So this b plus 2d will be cancelled out from both sides, from numerator and the denominator, and it remains 2k plus 1 over 2k minus 1. Now next step is very important. Mostly what students do, they start from LHS. And after getting 2k plus 1 upon 2k minus 1, leave it. And then start from RHS and prove the same thing for RHS also. But though this method, that method is also correct. If you are not getting anything, then you can solve the question with that method also. But to make the concepts clear, we have to use the proper method. Always try to prove starting from LHS and ending at RHS. For this, you have to watch the right hand side of our proving. It is 2a plus b minus 4c minus 2d is to 2a minus b minus 4c plus 2d. And we already have 2k plus 1 is to 2k minus 1. We have cancelled b plus 2d and b minus 2d. And in right hand side, we have to bring 2a plus b minus 4c minus 2d is to 2a minus b minus 4c plus 2d. So one thing which you can do is multiply by the denominator 2a minus b minus 4c plus 2d in the denominator and in the numerator. Now you have denominator 2a minus b minus 4c plus 2d which you have to bring, and one more extra step 2k minus 1. And in numerator you have to bring 2a plus b minus 4c minus 2d. So how to bring that? For this you will again use our results which are given in the question, that is a equals to bk and c equals to dk inside this bracket of numerator. So in place of a it becomes bk minus b minus 4 into dk plus 2d. Write the denominator as it is, 2k minus 1 into 2a minus b minus 4c plus 2d. As in the denominator, we have to bring this step only, this term only, 2a minus b minus 4c plus 2d. So we will not eliminate this term. So we have not to do anything in denominator. So first we write the denominator. And in the numerator, 2k plus 1 into, in first two, we will use a square bracket this time. In first two, b is common into 2k minus 1 plus, in place of plus, if we use minus 2d common, it will be better. So when we take minus 2d common, it is 2k minus 1. And in the numerator now, 2k minus 1 is common. 2k plus 1 is already outside the bracket. 2k minus 1 is common in the bracket into b minus 2d. Over denominator has also a term 2k minus 1 into 2a minus b minus 4c plus 2d. This time this 2k minus 1 and 2k minus 1 will be cancelled out. So we get 2k plus 1 into b minus 2d over this 2k minus 1 cancelled out from the denominator. So 2a minus b minus 4c plus 2d, which is the denominator of our proving. And then we use the product in the numerator. Denominator is already there, so we write it as it is and expand the brackets. So 2k into b means 2bk plus 1 into b is b plus b, then 2k into minus 2d is minus minus 4dk and minus 1 into d is minus 2. This 2k into minus 2d is minus 4dk and 1 into minus 2d is minus 2d equals to, and now we know that bk equals to a. So in place of bk we write a plus b minus dk equals to c. So in place of dk we write c plus 2d over 2a minus b minus 4c plus 2d equals to, it is RHS, hence proved. So hope you all must have understood what should we do after getting the lowest term 2k plus 1 over 2k minus 1 to bring the denominator, means consequent of the right hand side, we will multiply the numerator and denominator both with 2a minus b minus 4c plus 2d. So it is 2k plus 1 into, in place of a when we substitute bk, and in place of c when we substitute dk and factorize it, it is also given 2k minus 1, which will be cancelled out from the denominator. And when we expand the numerator, brackets of the numerator, it is giving the result which we require, hence proved. So very easy method. We are using the terms of right hand side. So one more important doubt from the students. It can also be solved using the same method. As in this also, A is to B is proportional to C is to D is given. Means this result is common for both the questions. A equals to BK and C equals to DK. We can consider it as given in the question. A equals to BK and C equals to DK. And we have to prove that 3A minus 5B into 3C plus 5D equals to 3C minus 5D into 3A plus 5B. So LHS 3A minus 5B into 3C plus 5D equals to, in place of A we use BK. So it is 3BK minus 5B into 3C is 3DK plus 5D. Now B is common from the first bracket, so 3K minus 5, and D is common from the second bracket, so 3K plus 5 equals to, now we observe the right hand side, in which in place of 3C plus 5D we have to bring 3C minus 5D, and we have 3K minus 5, and we have to bring minus 5D. So if we multiply D with the first bracket, it is giving minus 5D, and we have to bring plus 5B. And if we multiply this B with the second bracket, it is giving plus 5B. So interchange the places of B and D. D should be written with the first bracket. As in multiplication, on changing the order, product remains the same. So D is written with first bracket and B is written with second bracket. Equals to, when we open the bracket, it is 3DK minus 5D, and multiply B with the second, 3BK plus 5B. So DK is C, 3C minus 5D into BKC plus 5B. So very easy, it is equal to RHS, hence 2. Hope you all must have understood. Otherwise, ask in comment box. Then the next doubt is question number 1F. We have to change only the places of B and D to prove it. In question number 1, F A plus B, the main concept behind all these questions is same as the two questions which are discussed before this. A plus B upon C plus D equals to, we have to prove under root 2A square plus 7B square over 2c square plus 7d square. We again will start with LHS equals to a plus b upon c plus d, and then write the values of a and b. So the value of a is bk. So in place of a, we write bk plus b over value of c is equal to dk. So dk plus d. Now if we take b common into k plus 1 over d common into k plus 1. So k plus 1 will be cancelled out. Now we have b by d equals to, as we have to bring a square root. So if we make the square root, b by d becomes under root of b square by d square. Okay. Now we have to bring 2c square plus 7d square in the denominator. Always try to multiply the terms in the denominator to the denominator and with the numerator also. B square is already there into 2c square plus 7d square. So it is again under root of. In the denominator, we have to bring the term 2c square plus 7d square. So we write it as it is without multiplying. But in the numerator, we have not to bring 2c square plus 7d square. So in this, use the result. A equals to bk, c equals to dk. Only c is there. So in place of c, we write dk whole square plus 7d square equals to, if it is not clear to you, I am writing it again. Under root of b square into 2 into dk whole square plus 7d square, and in the denominator d square into 2c square plus 7d square, as we have to bring it in denominator. Then in the next line, again denominator is same. C square plus 7d square, and in the numerator, when we open the bracket, d square k square plus 7d square. So d square is common. When we take this d square common, it is 2k square plus 1 over d square into 2c square plus 7d square. So d square from the numerator and denominator will be cancelled out. Next line is b square into 2k square plus 1 over d square already cancelled out. So 2c square plus d square equals to the square root of, now we open the bracket, so 2 b square k square plus b square into 1 b square over 2c square plus d square. Clearly in place of bk, if we write a as bk equals to a, so it is 2a square plus b square over denominator is 2a square plus, actually it was 7. This is 7. So when we observe at the right hand side, we can make the correction also, which is equal to RHS, hence proved. So the same method we have used as we have used in previous two questions also. Okay. Next out is H, question number 1H. I am writing it. Can you solve this now yourself? A square plus C square into B square plus D square equals to AB plus CD whole square. With the same result, we have still the same things. A equals to BK, C equals to DK. It is common for all these questions. When we have started the discussion, it is given that A is to B is proportional to C is to D. So we have assumed it to be K. So A by B equals to C by D equals to K, and A equals to BK, C equals to DK. So this is the result which we have used in next parts. In question number 1C, in question number 1F, and we will use it in 1H also, that A equals to BK and C equals to DK. So we again start with the same. LHS equals to A square plus C square into B square plus D square. In place of A, we use BK whole square, plus in place of C, we use DK whole square into B square plus D square equals to, now when we open the bracket, B square K square plus D square K square into B square plus D square will be there. So first, from first bracket we can take K square common. So it is B square plus D square into, in second bracket, it is already B square plus D square, means K square into B square plus D square whole square. And we have to bring AB plus CD whole square. So we write K into B square plus D square inside the bracket whole square equals to, multiply K with the two terms, KB square plus KD square whole square equals to, again it is BK into B into B square plus DK into D whole square, in which BK equals to A. So AB plus DK equals to C. So CD whole square, which is equal to RHS, hence proved. So all the questions of part 1 we have discussed. If anyone has doubt, then write in comment box, or we will further move to the next discussions.